Alright, hello everybody. Just a real quick example here to talk through some of the Chapter 6 stuff on construction engineering with the mobile equipment power requirements. The only difference here I really wanted to emphasize were some of the different items that you're going to come across with tracked vehicles. There's a good example in the book. There's a good example in the lecture notes for wheeled vehicles. So I'm just going to throw in just a couple real quick items about tracked vehicles. So question here is using a crawler type vehicle, track and wheel, rutted, no maintenance earth consisting of wet clay loam. Site is up 6%, vehicle weight is 10 tons, load of 6 tons. So easy one. What's the total resistance and what's the usable force for this vehicle? So just starting with we're going to get the total resistance here. Remember that it's going to be your rolling resistance plus your grade resistance. Alright, so let's start with the rolling. Alright, so the rolling resistance, you'll go to table 6.1. So 6.1, I believe is right here. So this is table 6.1. You're going to look up the type of vehicle. So we've got over here is what you've been using, rubber tires over here, steel tires. Here's our crawler type. And just look over here on the left side, we're looking for this one, earth, rutted, muddy, no maintenance, 140 to 180. So we're going to use 160 for this problem. So 160, and that's pounds per ton. Our vehicle weight here, we are going to use the weight plus the load. So 16, we get 2560. Okay. Now our grade resistance. So this one's pretty easy. It's the same kind of thing. We're just using the 20 pounds per ton for every percent grade, and in this case it's a 6% grade. So times 6 is going to equal 120 pounds per ton, and again times 16, and it equals 1920 pounds. Okay. So then we can find our total resistance. Our total resistance here is going to be 2560 plus 1920, which is equal to 4480 pounds. Alright, one other thing we'll do real quick is if we wanted to do an equivalent grade for both of these. Really the only one that you have to do, this one already you know is 6%. So if we want to find an equivalent grade right here for the rolling resistance, you can do that. Just remember that that same equation we used with 20 pounds per ton. So we got right here 160 was our number. So if it's 160 pounds per ton and you divide by 20 pounds per ton, and that's for every 1%, you end up with a value of 8%. So that's the equivalent grade of the rolling resistance. So the equivalent grade of the total resistance is just 8 plus 6, 14%. Alright, so back to the problem at hand here. Part B is just the usable force. So here I just want you to use a slightly different table, or at least a slightly different value of a table that you've already seen. So usable force equal to coefficient of traction times the weight on the drive wheels. Okay, so your coefficient of traction is going to be from table 6.4, which is this one. Table 6.4, go back to the problem, see that it's wet clay loam, and just remember you're going to use 0.7 for the crawler tracks. So you have this guy, 0.7, and then the weight on the drive wheels, and this is the only tricky part. Most other problems it'll give you what it consists of. Here it doesn't, and that's because it's a crawler type vehicle, which means that you just use the total weight. So that's just times 16, and you get actually, let me punch that in tons. You can transfer it to pounds for some of your future calculations, but I'll just keep it consistent here. So 16.7 equals 11.2, and that's tons. So you can convert that to pounds. You can continue on with pretty much the same calculations that you did for the wheeled vehicles, but just a couple things to watch out for in there that you don't get stuck on. Alright, so that's it.